Welcome to Quick Learn tutorial series. In this video, I will explain you data transfer instruction of 8051 microcontroller. This is lecture number 14 of microcontroller series. So before I explain data transfer instruction, we must know about what do you mean by instruction set of 8051 microcontroller and what do you mean by instructions. So instruction set are basically a group of instructions, and instructions are the command which is given to the microcontroller to perform some specific task. So that type of instruction is grouped into the instruction set, and this is also known as program. So in this video, I will explain you data transfer instruction of 8051 microcontroller. In this type of instruction or data transfer instruction, we only move data from one location to another location. In this type of instruction, we do not perform any operation like addition, multiplication, subtraction and division, or we do not modify or manipulate data. Here we simply move data or copy data from one location to other location. Now this is the syntax of the instruction. In this instruction, left hand side opcode is given and right hand side operand is given. So what do you mean by opcode? Opcode are basically used to identify the type of operation to be performed using this instruction, and operand are basically used to identify the source and destination of the data. So in case of data transfer instruction, we transfer data from source location to destination location, or from one location to another location. The location from where data is transferred is called source location, and the location where we place data or copy data is called destination location. So in case of data transfer instruction, here we perform or here we transfer the data from source to destination location. The transfer of data does not mean that we can delete data from the source location, but the data is still residing in the source. It just copied into the destination location. So this is called data transfer instruction. In case of data transfer instruction, we can transfer data between an internal RAM location and a special function register location without using through the accumulator. As we know, in 8051 microcontroller, we have 256 byte of data memory, that is called RAM, and this 256 byte of RAM is divided into two parts: 128 byte of internal RAM location, and that is also called general purpose RAM, and another 128 byte is allotted for special function register area. So using data transfer instruction, we can use to transfer data between an internal 128 byte RAM location and special function register area without going or without using the accumulator register. Next is, in case of data transfer instruction, we transfer data between the internal and external RAM by using indirect addressing mode. Next is, in case of data transfer instruction, the upper 128 byte, that is also called the general RAM location or data RAM, are accessed only by using indirect addressing mode, whereas the special function register are accessed only by direct addressing. So these are some important points related to data transfer instruction. Now the type of data transfer instruction. So basically there are three type of data transfer instruction. First is move instruction, second is push and pop instructions, and third is exchange instructions. So one by one I will explain you all the three type of data transfer instruction in detail. First is move instruction. In case of move instruction, we move or copy the content of source location to destination location. This is the syntax of the move instruction. This is the opcode, that is MOV for move instruction, and this is the operand. In any instruction, the destination is mentioned first and then source is mentioned. So this is the source location and this is the destination location. In this instruction, we move data from source location to the destination location. Now, in this type of instruction, the source location, it can any one of the special function registers, that is accumulator register, DPTR register, or it can be a 8-bit register of a selected register bank, that is R0 to R7. We know that in 8051 microcontroller we have 4 register bank, that is bank 0, bank 1, bank 2 and bank 3. Each bank contain 8-bit register and each register is a 8-bit register. So the source location can be a 8-bit register of a selected register bank, that is R0 to R7. It can also be a RAM memory location, internal RAM or external RAM. So in this instruction, the content of source location is copied into the destination location. So here I explain you number of different type of move instructions. These come into the category of internal memory instruction. Internal memory instruction means here we move data or copy data between the internal memory of 8051 microcontroller. So first instruction in this category is, so in this instruction we move or copy the content of RN register to the accumulator register, where RN is the 8-bit register of a selected register bank, that is R0 to R7 register. Accumulator is also an 8-bit register. So the instruction is move Rn comma A. This instruction tells that move or copy the content of accumulator register into the Rn register. Rn is any one of the register from R0 to R7 register of a selected register bank. And the reverse is also possible. Move A comma Rn. This instruction tells that move the content of Rn register into the accumulator register. Next instruction is, here we want to move an 8-bit immediate data to the accumulator register or to the Rn register or to a particular memory location by using direct or indirect addressing mode. So first instruction is move A comma hash 43H. Here hash indicate this is an immediate data and this instruction tells that this immediate data, it means 43H data is move into the or copy into the accumulator register. Next is move R6 comma hash 46H. Here hash indicate this is an immediate data. So this instruction tells that move 46H data into the R6 register. These two are the example of direct addressing mode. And next is move at the rate R0 comma hash 0E4H. Here hash represent this is an immediate data and at the rate R0 represent this is an example of indirect addressing mode. This instruction tells that here we move this immediate data into that memory location whose address mentioned into the R0 register. Next instruction is move DPTR comma hash 0F2A4H. Here this is an immediate data. This immediate data is 16-bit data because DPTR is basically a 16-bit register. So here we want to move 16-bit data into the DPTR register. So it is a 16-bit data. This immediate 16-bit data is moved into the DPTR register. Next instruction is move 50H comma hash 80H. Hash represent it is an immediate data and 50H represent this is the address of the memory location where we want to store the data. So this instruction tells that move 80H data into this memory location. Next is here we move the content of memory location to the accumulator register or accumulator register content into the memory location by using direct or indirect addressing mode. So the example of this type of instruction is first is move A comma 56H. 56H indicate the memory location. So this instruction tells that
content stored in 56H memory location is copied or moved into the accumulator register. Next instruction is move 89H, A. This instruction tells that the content of accumulator register is moved into the or copy into this memory location. These two are the example of direct addressing mode. Next is move A, @R0. This is the example of indirect addressing mode. This instruction tells that the data which is stored in a particular memory location whose address given in the R0 register. I will explain once again. This instruction is move A, @R0. Here @R0 indicate that this is the example of indirect addressing mode, and this instruction tell that the data or the content is stored in a particular memory location whose address is mentioned in the R0 register is copied into the accumulator register. Next instruction is move @R1, A. This is also the example of indirect addressing mode because @R1 is given in the instruction. This instruction tells that move the content of accumulator register in a particular memory location whose address is given in the R1 register. Now, next instruction is move the content of memory location to Rn register, or the content of Rn register is moved into the memory location by using direct or indirect addressing. First instruction in this category is move R4, 45H. Here 45H indicate this is the memory location and R4 is a particular register of a selected register bank. So this instruction tells that move the content which is stored in 45H memory location into the R4 register. Next instruction is move 65H, R5. This instruction tells that move the content of R5 register into the 65H memory location. These two are the example of direct addressing mode, whereas these two are the example of indirect addressing mode because @R0 is given here. So this instruction move 54H, @R0. This instruction tells that the content is stored in a particular memory location whose address given in the R0 register is moved into this 54H memory location. Once again I will explain. Move 54H, @R0 tell that the content or data is stored in a particular memory location whose address is mentioned in the R0 register is moved into or copy in the 54H memory location. Next instruction is move @R1, 45H. 45H is a memory location. So the content stored in the 45H memory location is move or copy into that memory location whose address given in the R1 register. Next is move the content of memory location to another memory location. Here we move or copy data from one memory location to another memory location by using direct or indirect addressing mode. So first instruction is move 45H, 68H. 45H is a memory location and 68H is also the address of memory location. So this instruction tells that the content is stored in 68H memory location is copied into the 45H memory location. So this instruction is the example of direct addressing mode. Next instruction is move 47H, @R0. This instruction tells that the content is stored in a particular memory location whose address is mentioned in R0 register is moved into the 47H memory location. This is the example of indirect addressing mode. Next category is external memory instruction. So in this type of instruction, we move the content of external memory location to the accumulator, or the accumulator content is moved into the external memory location. by using direct or indirect addressing mode. So here this is given in this type of instruction, the content of external memory location is moved into the accumulator register, or the content of accumulator register is moved into the external memory by using direct or indirect addressing mode. So these are the example of external memory location instruction. First example is move x a comma at the rate r0. Here this x indicate this is an external memory instruction. It means by using this instruction we move data from external memory location. So first instruction tell that move x a comma at the rate r0. The data is stored in a particular memory location whose address is stored in the r0 register is moved into the accumulator register. Next instruction is move x at the rate r0 comma a. This instruction tells that data is stored in accumulator register, copy into that memory location whose address is specified in the r0 register. Next instruction is move x a comma at the rate dptr. Here x indicate data is accessed from external memory location. So in this instruction we copy data from a particular memory location whose address given in the dptr register and move data into the accumulator register. Next is move the content of program memory. In this type of instruction, we move or copy the data from program memory. So first instruction is MOVC A comma at the rate A plus DPTR. Here C indicate data is accessed from program memory or code memory. And this instruction tell that at the rate a plus dptr says the content of accumulator register is added with the content of dptr register and the result is the address of memory location where data is present. So that data copy into the accumulator register. Next instruction is move c a comma at the rate a plus pc. PC is the program counter register. So this instruction tell that. So here at the rate A plus PC tell that the content of accumulator register is added with the content of program counter register and the result is the address of the memory location where data is stored. So that data copy into the accumulator register. So these are the example of move instructions. Next data transfer instructions are push and pop instructions. These two instructions are stack related instructions. So first we know about what do you mean by stack. Stack is basically a memory location, or we can say that stack is a block of memory in 8051 RAM which is used to store data temporarily. Whenever microcontroller dealing with interrupt, so to store the content of program counter, PSW flag register, here we use stack area of memory. So in short, we can say that stack is a part of memory in 8051 microcontroller. And here we store data temporarily. So here I written stack is basically a section of RAM in 8051 microcontroller, or we can say that it is a block of memory in 8051 microcontroller which is used to store data temporarily, and there is a register inside the CPU to point that memory location or stack. That register is called stack pointer. This stack pointer register in 8051 is a 8-bit register. It can take a value from 00 to FFH. When the 8051 microcontroller is initialized, the stack pointer register contains the value of 07H. This is the important point. When 8051 is initialized, the stack pointer point out the memory address, or stack pointer register contain the memory address 07H. This is the default value of stack pointer. So this means that the RAM location 08H is the first location used for the stack. Now there are basically two operations performed in stack. First is push operation and second is pop operation. So in case of push operation, we store CPU register data into the stack, that is known as push operation. And if we retrieve data from the stack, that is called pop operation. So in simple word, we can say that if we put data into the stack, that is known as push operation, and if we retrieve data from the stack, that is called pop operation. So when we perform push operation, the stack pointer register is automatically incremented by 1. And when we perform pop operation, the stack pointer register is automatically decrement by 1. These are the important point related push and pop operation. With the help of this point, we can understand easily what is the push and pop instruction in 8051 microcontroller. Now here with the help of example, I will explain you what is push and what is pop in stack. As I have already told, if we push or if we store any data element into the stack memory location, that is called push operation. And when we retrieve data into the stack area, that is called pop operation. Store data, that is called push. If we retrieve data, that is called pop operation. So stack is work in last in first out concept. It means the data put into a stack in last that come out from stack in first. Now first I explain the push instruction. By using push instruction, we store data into the stack, or we can say that the content of any CPU register, just like accumulator register, DPTR register, or R0 to R7 register of a particular register bank, content is stored into the stack by using push instruction. And when we push data into the stack pointer is incremented by 1 automatically. What is a stack pointer? As I have already told, stack pointer is a register that point out the top address of the stack. So before pushing data into the stack pointer is incremented by 1. So here with the help of this example, I will explain you how push instruction will work. So as I have already told, by using push instruction, we push the content of any CPU register into the stack area. So first we want to load the CPU registers. So we use this instruction. First instruction is move R6, hash 25H. Here hash 25H is the immediate data and R6 is one of the R0 to R7 register of a particular register bank. So this instruction tells that copy this immediate data into the R6 register. So R6 register is loaded with 25H data. Next instruction is move R1, hash 12H. This instruction tells that this immediate data is copied into the R1 register. So R1 register is loaded with this value. Next instruction, move R4, hash 0F3H. This instruction tells that this value, this immediate data is copied into the R4 register. So when these instructions are executed, the R6, R1 and R4 registers are loaded with this immediate data. Now the push instructions. First push instruction is push 6. This instruction tells that push the content of R6 register into the stack area. Or we know that when 8051 microcontroller is initializing, the stack pointer contain the value of 07H, or we can say that the stack pointer point out the initial value, that is 07H. This is the default value of the stack pointer. And if we want to push any data into the stack, this stack pointer is incremented by 1. This means that the RAM location 08H is the first location which is used to store data in the stack. When first instruction is executed, that is push 6. This instruction tells that push the content of R6 register into the stack, and R6 register contain 25H. So after executing this instruction, 25H is stored in the 08H stack location. Next instruction is push 1. When this instruction is executed, this instruction tells that push the content of R1 register into the stack. So before pushing the R1 content into the stack pointer is incremented by 1. So the next value of the stack pointer is 09H. So when this instruction is executed, the data is stored into the 09H memory location. Next instruction is push 4. This instruction tells that push the content of R4 register into the stack. So the next memory location where we push the content of R4 register, the stack pointer is incremented by 1. So 09 plus 1, the next memory location is 0A. So when this instruction is executed, we store data into the 0AH memory location. Next instruction is pop instruction. This instruction is used to retrieve data from the stack, or this instruction tells that pop the content of stack and store that content into a particular CPU register. So when data pop from the stack pointer register is decremented by 1 automatically. So here with the help of this example, I will explain you how pop instruction get work. Suppose this is the stack and this is the address where data is stored in the stack. So by using pop instruction, we retrieve data from this stack. So the stack pointer point out the top address of the stack, that is 0B. When we pop data into the stack pointer is decremented by 1. So these are the pop instructions. First instruction is pop 4. This instruction tells that pop the data from stack and stored in R4 register. So when this instruction is executed, the microcontroller pop the content from 0B location and store data into the R4 register, because stack pointer first point out 0B value. So the content from 0B value is popped first. And when data pop from the stack pointer is decrement by 1. So the next value of stack pointer is 0A. Now the next instruction is pop 1. This instruction tells that pop data from the stack and store in the register 1. When this instruction is executed, we pop data from 0AH location and store into the R1 register. When this instruction get executed, the stack pointer again decremented by 1 and point out 09H memory location. Next instruction is pop 6. This instruction tells that pop the data from stack area and store in the R6 register. So where we pop the data? From 09H location, because stack pointer point out the 09H location. So from 09H we pop data and store into the R6 register. When this instruction is executed, again stack pointer is decremented by 1. So in this way pop instruction is executed. Next instruction is exchange instruction. As the name suggested, in exchange instruction, here we exchange the content of accumulator and a byte variable. So these are the syntax of exchange instruction. Exchange A, Rn. This instruction tells that here we exchange the content of accumulator register and the Rn register. We do not perform any operation, we do not manipulate data, we only exchange the content of Rn register and A register. Next instruction is XCHA, 54H. This instruction tells that the data stored in 54H is exchanged with the accumulator content. Here we do not perform any operation, we only exchange the content of accumulator register and the content of this memory location. Next instruction is exchange A comma at the rate R1. This is the example of indirect addressing mode. Here we exchange the data which is stored in a particular memory location whose address is given in R1 register from the accumulator register. So these two are the example of direct addressing mode and this is the example of indirect addressing mode. Next instruction is XCHD. Exchange. This instruction tells that exchange lower digit of accumulator with the lower digit of memory location specified in the instruction. So these type of instruction is XCHD A, 35H. Here we exchange only the lower digit of the accumulator content with the lower digit of the memory location content. So these are the data transfer instruction of 8051 microcontroller. Hope you like the video. Please keep watching my video and keep sharing my videos.